Hello, good morning, dear students. So today we shall solve some examples question so that you can understand very well, and it will really help you to this question. So here goes the example 8 of your NCERT. So it is based on our understanding that we made yesterday about 1 and 1 2. You can see show that a function here function f from n to n represents a natural number and this also natural number. That means from domain is a natural number and codomain is natural number. Means function is defined from natural number to natural number, natural number to natural number. It is said. And how the function is defined? Okay, function is from n to n and fx is equal to twice x. Fx is equal to twice x. Clear? That means if you put here x, you will get 2x here. Function of x is your 2x. So for example, if I take 1, I will get what is the image of 1? I will get 2. If I take 2, I will get 4. If I take 3, I will get 6. If I take because fx is equal to twice x. If I put x, I will get double of x. So if I put x as 4, I will get double of x. I will get 8. Same thing, if I put x as 5, I will put double of x. I will get 10. This is the thing. So it is said that we have to show it is 1 1 but not 1 2. And what does 1 2 means? That we can clearly see from here that it is 1 1. But the thing is that only understanding is not enough. We have to express it also. We have to express that how it is 1 1 and why it is not 1 2. As we can say, 1 2 means what? 1 2 means all the element of codomain should also occupy. But you can see there is 1 is there, 3 is there, 1 3 because natural number also consists 1 3 5 7. They are also here. But what you can see, they are not an image of any pre-image. Means they are not the image of any of the element of domain. So we cannot say it is onto because some of the elements are left out. Because we know that natural number consists of what? Natural number consists of the series from 1, 2, 3, 4, 5, 6, 7, 8 and so on. So the image of 1 is what? 1 is 2, 2 is 4, 3 is 6, 4 is 8. But what about 3? What about 1? What about 5? What about 7? Are they image of anybody? Do you find any image of 3 here? No, we cannot find any image of 3 because to have the image of 3 we need 1.5 because double of 1.5 is only 3. But 1.5 is not included in natural number. Natural number is only start from 1 to infinity. So 1.5 is not included in natural number. So to be the image of 3, we need 1.5. So 1.5 is not the number. So we can see there is no any image for 3. There is no any pre-image for 3. There is no any pre-image for 5. So these are the left out element. So we can say this is not onto. And we can see for every individual element of domain there is a single image. So from here also we can clearly say that it is a 1 1. But thing is that only just understanding this is not enough. We have to express also. How to express? Let me show the tricks. Now let us write a solution here. How to write solution? First of all, we shall prove 1 1. We shall prove 1 1. How to prove 1 1? So let us take two element of domain. Let us consider let fx1 is equal to fx2. I consider like that because we cannot take any desired element, right? Because why? Because it is an infinite series. It is an infinite function. There is so many numbers of elements are there. So it is not possible to solve with all the every individual element, right? So we shall take some variable. We will solve the question with the help of some variable. So we have chosen two elements from domain x1 and x2. We have considering that the image of both the element is same. Okay. Now if this is the way, try to understand. So we are considering that both the image or both the element of domain has the image y. And if you could prove that both the elements are not different element, they are the same element. That means x1 is equal to x2. Then we can say it is 1 1. Means हर एक का image का हर एक element का हर एक image है. But if we found that x1 is not equal to x2, that is not 1 2. It is a manual function. So now you will be confused now. Let us solve few of the questions so it will be clear for you. So we have considered let fx1 equal to fx2. Now what is the definition of fx? Fx is equal to 2 i's of x. So you can write that twice of x1 is equal to twice of x2. Now what if we cancel 2, what we come to know that x1 is x2. That means x1 and x2 are not two different elements, they are the same element. That is why that a single pre-image has a single image only, a single element has a single image. So this clearly state that it is a one function. So it is what? It is one function. Okay. Now let us move to proof onto. Now onto. As it is said that it is not onto, and we also clearly find that it is not onto. But thing is that how to show. So when we have to prove that something is not on one or something is not onto, we can take the help of an example. So as we can see clearly that 3 has no any pre-image, but 3 is in the codomain, but 3 has no any pre-image. That means 3 is not an image of any element, right? So how can you prove that? That is a very interesting thing. So let us find it here. Let us solution. Now let us do onto. Okay, there is no any specific formula. It is a tricks. Everything is tricks. If you could prove in some other way also, that's also okay. No problem is there. So onto. So we already know that fx is equal to fx equal to twice of x. And what is twice of x? Twice of x is the image. What is the image of x? Image of x is twice x. And let us consider, and this image will be consisting from where? From y only, right? That 2x. 2x is what? 2x is the image. And where is the image located? Image located in the set of this codomain, and I consider the set of codomain as y. So 2x equal to y. So consider 2x equal to y. Okay. So if I say that let 3 belong to set of y. Let 3 is a element in, there is 3 is an element in the set of codomain. 3 is an element. So I consider this 3 belong to y. Obviously 3 belongs to y. So I can say that. So now let us see. Therefore 2x is equal to 3, and what is the value of x? X is equal to 3 by 2. Oh my god. So we can see that 3 by 2 means what? 1.5. That means x equal to 1.5. But this 1.5 is not included in the set of domain. And what is x? X is a set of domain, which is not included in the set of domain. You can see for 3 belong to y. 3 belong to y. 3 belong to y. There is an pre-image which is 1.5. But this 1.5 is not belong to the natural number. So it is clearly states, it is clearly defined from here that the 3 do not have any pre-image. 3 do not have any pre-image. That means there is 3 is not an image of any of the element of domain. This is clearly said. So we can clearly say that. So how to write last line? This is the way we can prove very easily. So you can use your own way also, no problem. So we can say that. For 3 belong to the set of codomain, there is no pre-image. There is no pre-image in the set of domain. So what we can say from here, that means 3 is not an image. 3 is not a image of any element. So what we come to know, if 3 is left out, and for being onto every element of the codomain should occupy it. That means they should have some wife, right? So therefore it includes that. Therefore it is not onto. It is not onto function. It is not an onto function. I hope it is very clear to every one of you. So let us proceed to another example. P. So here goes another question. Nice question. It says that prove that a function from R to R, domain to codomain, and function is given. So what is domain here? Now this is a little change question from the earlier question. In earlier question, the domain was a natural number, and the codomain was also a natural number. There was a limitation. But thing is that it is a natural number. It's a real number now. From R to R, R represents what? Real number. So real number includes all the rational, irrational, decimal, fractional, everything is included, so there is no restriction. Okay, and function is from R to R, real number to real number. And how it is defined, how the function is defined, fx is equal to twice x, means for every x there will be some 2x, and this 2x is y. 2x means what? 2x is the element of this set. Clear now? Very good. Now what do you say? Now see, you can say for every element you will get some different image. If I take 1 here, you will get 2. If I take minus 1, now I can take minus also. If I take minus 1 also, I will get minus 2. If I take minus 1.5, I will get minus 3. If I take plus 1.5, I will get plus 3, because twice of x, right? So now we can see there is a very interesting phenomena, that obviously every set of domain will have some pre-image. Every set of domain will have some image. So we can, it is clearly visible that it is going to be 1 1. So now only it is the enough, we have to show also, we have to prove it also. How to prove it? As we have the format, let, what is the consideration? Let fx1 is equal to fx2. If fx1 is equal to fx2. So how the fx1 is defined? Fx1 is defined the same way, twice of x1 equal to twice of x2. So if you cancel 2, what you come to know that x1 is equal to x2. This is the system, this is the way you can proceed with. That means x1 and x2 are not two different elements, they are saying about the same element. So it is a 1 1. Therefore the function is 1 1. Therefore the function is 1 1 function. Okay, we are clear. Now what about onto? Let us go on proving this 1 1 function. Write it 1 1. What about onto? Onto is monotrix. So as it said, it's an onto. Onto hey. So let us prove. Let us see how to do it. So as we already know that fx is equal to what? Fx equal to what? Twice x. And what this twice x means? Twice x means y. Twice x means y. So you can see that means x is equal to what? X is equal to y by 2. X is equal to y by 2. So from here we can create a different dependency. Here we can say that instead of fx, now I can put fy by 2, right? As we already know now, fx equal to twice of x. So we can write fx equal to twice of twice of x, twice of or we can say fx equal to twice of x means what? fx means what? Now the value of x means what? Y by 2. So f y by 2 and means what? This is twice x, and twice x means what? Y. So what we come to know from here? Very interesting. Look here. That for every y there is some pre-image, that is your y by 2. Because what it is the image, and what is the pre-image of this y? It is y by 2. Means the function of y by 2 is your y. The function of y by 2 is your y. Means function of this element is this. For every y there exists some pre-image. Now you can see, you can say anything. If you take 3, what is the pre-image of this? It will be 3 by 2. If we take minus 5 also, what is the pre-image of this? Minus 5 by 2. That means whatever element you can put here, anything, just you will get some required or some desired pre-image in the set of domain. So we can say that for every y there exists some pre-image. For every element, or for every y belong to the set of codomain, there exists some pre-image. इसके लिए कुछ हर एलिमेंट का कोई ना कोई कोई ना कोई प्री इमेज है, ऐसा नहीं है कि किसी का बाकी है. So we can write a last statement here for all. This is a formula for all y belong to set of codomain. This capital Y denotes the set of codomain. Okay, there exists, this is a symbol for there exists for all y belong to capital Y, there exists a. Means for every y there exists some pre-image. Which is belong to the set of domain such that fx is equal to y. Means such that the pre-image, what is the function of x? X is y. So here we can clearly say that this statement is very important statement. It's a mathematical way of expressing. So we can say that therefore the function is on to. Therefore the function is on to. I hope it is very clear. Very nice. Sir. So hello. So here goes our next questions and interesting questions. It says that show the function from n to n. Means n to n means what? Natural number to the natural number. Natural number to the natural number. Domain is natural number, codomain is also natural number. And it is given that function of 1 and function of 2 are equal. That means function of 1 and function of 2 both has the same image. 1. Function of 1 is also 1. Function of 2 is also 1. It's already given in the question. Okay. And how is fx defined? Fx is defined is that fx is equal to x minus 2. For example, if I take 3, so what is the image of 3? 3 minus 1. 3 minus 1 is 2. If I will consider as 4 as a pre-image shadow domain, so what is the image of this? 4 minus 1. 4 minus 1 will be 3. Now you have to prove that for every x is more than 2, and for all x more than 2 this is eligible. But for the 2 and for 1 already it is given. The function is given. Okay? We have to prove that it is on 2 but not 1 1. You have to prove that it is on 2, it is 1 1. Definitely we can clearly see that it is not 1 1, because you can see this both pre-image has a single image. Okay, many 1. It is many 1. So here we can easily prove 1 1. Look here. How to prove 1 1? See for once 1 1. Very simple. So here fx1 is equal to fx2. X1, a function of 1 and function of 2 are equal, because function of 1 is also 1 and function of 2 is also 1. But can you say that 1 is equal to 2? Definitely not. 1 is not equal to 2. Therefore, what we can say that here fx1 is equal to fx2, but x1 is not equal to x2. Therefore, it is not 1 1. It is not 1 1. Simple. Finish. Now what about onto? What about onto? See, onto means what? All the element of codomain should have some pre-image. Should have some pre-image. Right? Now if you take 4, what do you think? What will be the pre-image of this? 5, definitely. 5 minus 1 is 4. 5 minus 1 is 4. If you take 6, what is the pre-image? Obviously, it will have 4 or 5. Okay. So yeah, 4 ka 5. If you take now 5, what is the pre-image? 5 minus 1 is 4. So 6. 6 ka hoga 5. So for every element in codomain there exists some pre-image in a set of domain. So this function is clearly visible that it is a onto function. So how to prove? There are so many ways. We can write in a statement also, we can use a proof also. So let us do here. So here already given that fx is equal to x minus 1. And what is x minus 1? It is an image, so which is also equal to y. That means x minus y equal to x minus 1 equal to y, and here x is equal to what? X is equal to y plus 1. X is equal to y plus 1. That means in place of this x I can use x plus 1. So function of y plus 1 is equal to what? Is equal to y. So what we come to know that for all y there exists some pre-image. For all y, because what is the function of y plus 1? The function of y plus 1 is y. That means what? For all y there exists some pre-image. So we can write for all y belong to set of codomain, there exists some image in the set of domain such that fx equal to y. Therefore it is onto function. therefore it is an onto function. I hope it is clear. Very nice question. So it's okay. There's one more example, you can clear it up. Nice, very interesting questions are there. P. So let us proceed another example. Example number 11. What this example says, come on, try to understand. Show that the function from real number to real number defined as fx equal to x square, okay, is neither 1 1 and onto. Very nice. What is say? The function is given from the real number to real number, real number to real number, and how the function is defined? For every x there is some kind of x square. This is the question. This is the, and what is x square? X square is the element in the set of codomain. Very nice. So now try to understand. It is said that you have to prove it is not 1 1 also, it is not onto also. Very simple. Very simple. You just use your common sense here. If I take here 2, now tell me what is the square of 2? 4. Definitely. Now if I take minus 2, because minus 2 is also exists in the relation, right? Also exists in the real number. So what is the square of minus 2? Square of minus 2 is also 4. Yeah. So you can see that these two different elements, have the same image. That means it is x1 and x2. x1 and x2 has a single image, but x1 and x2 is not equal also, they are unequal. So it is clearly stated it's not 1 1, right? It is not 1. So you can take the help of this example to prove this statement. So solution, very simple. Let us move on proving 1 1. So very simple. So here let x belong to the set of domain. Let x belong to the set of domain. It is the set of domain. This set of domain, and this y, and this is the element. Okay, very good. Let x belong to the set of codomain. So here x means what? Let 2 and minus 2. Let 2 and minus 2 belong to the set of domain. So therefore here we found that function of 2 is also 4, and function of minus 2 is also 4. That is we can say that function of 2 is equal to function of minus 2. Function of 2 is equal to function of minus 2, but 2 is not equal to minus 2. 2 is not equal to minus 2. That is, so why here what we can say here वही बात है कि, so what you can say, they are not different element. So it is what? So it is not 1 1 function. It is not 1 1. It is not 1 1. It is not 1 1 function. Okay. Because already we know that what is 1 1. If fx1 is equal to fx2, but if x1 is not equal to x2, it is not 1 1. Same thing is happening in this case also. You can see, you can relate the relation. You can relate this one. Okay. So it is already we have proved 1 1. Now what about onto? It is not onto also, as the question already referred that it is not onto. So we have to use some tricks to prove it. So onto. Now let us use our common sense. Why it is not onto? Why it is not onto? Because now consider, because as it is a real number, so there can be positive number, decimal number, irrational number, rational number, anything it should be there. Now if I take it minus 2 or minus 4, you see minus 4. Now you tell me, is minus 4 can have any pre-image? Because pre-image is x, and the image will be x square. Now you just try to think, does square of anything will give you negative numbers? We already know from class 7 onward that square of anything will make it positive. If I take minus also, it will make positive. If I take plus also, it will make positive. That means there is no possibility to get negative in the real number. Though negative is there in the codomain, but this negative value has no any pre-image. So it is left out, and for being onto, not a single element of the codomain should left out. Everybody should have some y, should have some pre-image. So we can clearly know from here. So how to use in statement? We can see here. We can use it by the, you have an example also, and yeah. So look, very interesting. We can do here like that. Nah? We can prove 2-3 different methods. There is not a single method. Many ways are there to prove this. So let us consider let minus 4 belong to the set of codomain. Okay, that means what? Minus 4 will be equal to some x square, because we will know that y is equal to x square. That means for being present, for every y there should have some x square. So these are things. So look here. I have this clear because y means what? Y means x square. That means minus 4 is some image I'm considering. It is consideration. So if I transfer this square this side, so what will become? Root of minus 4 which is equal to x. Oh my god. Is it possible? What is this number? It is not a real number. It is an imaginary number. So we can say that here minus 4 is not belong to the real number. Oh my, it is not belong to the real number. Root minus 4 is not belong to the real number. So we can say that minus 4 has no pre-image. Has no pre-image. It has no pre-image. It has no pre-image. Minus 4 has no pre-image. So it is not onto. It is not onto. It is a special case. Very nice, interesting point. So there is one more way to prove is there. Let me show here in this line side. Point here. So we already know that fx equal to x square and this x square equal to y. That means x square equal to y. That means x equal to root of y. Okay. Now in place of this x, I will use root x. Function of root y is equal to y. Now what about the negative value? But you can see, but negative value, negative y of root is not belong to the real number. So it is not onto. So it is not onto. Finish. Simple. Yes.